this lesson, we will look at two operations that we can do with sets, union and intersection. At the end of this lesson, we will develop a few properties of these two operations. Recall that for our connectors and or, we have the following two diagrams. If you need a quick refresher, check out the Venn diagrams video. The main idea of the union and intersection is to define a new set based on the shaded regions that we see here. For A and B, we call the shaded region the intersection of the two sets. And for A or B, we call the shaded region the union of the two sets. Here's a quick summary of those points I just mentioned. For the union, we write it like this: A union B. For the intersection, we write it like this: A intersect B. Try to determine which elements here are in the union and intersection of the sets A and B. If you need to, flip back to the last slide to help you out. In the union of A and B, we're going to have all of the elements from both A and B. So 1, 4, 3, 2, 5, and 7. Remember that order doesn't matter. So if you have these numbers in a different order, that's totally okay. For the intersection of A and B, we look at all of the elements that A and B share. In this case, the elements that they share are 3, 2, and 5. And again, order doesn't matter here. The union operation has some properties that might be nice to know. Take a moment to determine the union of A and B, as well as the union of B and A. In this case, A and B don't share any shapes, so A union B is going to consist of all 7 of these shapes. And the same is going to be true for B union A. It's going to contain all 7 of these shapes. Maybe you wrote them down in a different order, and that's totally okay. So it turns out that these two sets are the same, and this is true always. So it's possible for us to write that A union B is always going to be equal to B union A. Next, what do you think A union with itself is? Well, for A union A, we're going to put in all of the elements that are in A and A. But there are only 4 elements in A, and once we list them once, we don't have to list them again. So here is the set A union A. It turns out to be equal to A. Finally, what do you think is A union with the empty set? Well, A union with the empty set, we should put in all of the elements in A as well as all of the elements in the empty set. So again, we're going to list these 4 elements that we have in A. The empty set doesn't contain any elements, so A union the empty set is just going to be these 4 elements here, and we can see that that is also equal to just A. The following slide summarizes some of the basic properties of the union operation that we just saw. Now, let's turn our attention to the intersection operation. What is A intersect B? And what is B intersect A? While looking at these two sets, it turns out that A and B don't share any elements, so the intersection of A and B should be the empty set. We can write this in one of 2 ways. We can write it like this using our curly braces with no elements inside, or we could write it as a 0 with a slash through it. So in this case, A intersect B and B intersect A are equal to each other. They're both the empty set, and it turns out that this property is true in general. Next, what do you think A intersect with itself is? Well, for A intersect with itself, we need to find all of the elements that A shares with A. Well, that's really just all of the elements that are in A. So it turns out that A intersect with itself is equal to A. Finally, what do you think A intersect with the empty set is? What elements do A and the empty set share? Well, they don't share any elements, so it turns out that A intersect with the empty set is also empty. And this is true in general. This slide summarizes the basic properties of the intersection operation we just discussed. Let's take a look at a couple examples here at the end of this lesson. Using the sets A and B, let's try to determine the following four things. A union B. This is all of the elements in set A put together with all of the elements in set B. And A has 6 elements, A, B, C, 1, 2, 3. B has 4 elements, but I've already got 3 inside of A union B, so I'm just going to list 5, 7, and Z. Next up is A intersection with B. This is the set of all elements that are shared by A and B, and there's only one shared element, and that is the number 3. For part 3 of this question, this is the cardinality of set A. How many elements are in set A? Well, we know that there are 6 elements in set A, and that is the cardinality of set A. And lastly, let's look for an element that's in B, but that's not in A. Now there are a couple of different elements we could choose. For example, 5 is an element of B, but we can scan through set A and we note that 5 is not an element of set A. So 5 would work, 7 would work, or the letter Z would also work here. All right, my little epsilons, stay positive.